we're asked to take this equation, 2 cos x tan squared x equals 3, 1 plus cos x. And actually, I'm going to expand it out straight away. I'm going to start my working right away and show that it actually becomes this hidden quadratic. Now remember, if you can't get there, then you can still do part B. That's quite important to know because sometimes it happens to all of us. We just can't quite. We make a mistake. We can't see where it is, but don't waste loads of time. There's still 6 marks here that you can use the answer to part A for. So in my final answer, there's just cos, i.e. I'm going to need to get rid of tan squared first of all. And I can do that by using the identity that tan is sine over cos. So it's going to be, in this case, sine squared over cos squared. And I can straight away cancel out that with that squared. Next up, I'm going to multiply through by cos x because I really don't want it on the bottom. So it will be 2 sine squared x is equal to 3 cos x plus 3 cos squared x. This is looking better now. I've got rid of the fraction, I've got rid of the tan. I just have this sine squared to sort out. But I can replace that because sine squared plus cos squared is identical to 1. I haven't written all these identities down. Maybe I should have just written them by the side. I'll just write them down here now. Tan x is equal to sine x over cos x. And now we've got the sine squared. I don't know why I'm using A. Sine squared x plus cos squared x is equal to 1. Now, technically, these are both identities. They're true for any value of x. So you put that little 3 lines in instead. So here, right, that means that sine squared is going to be 1 minus cos squared. Okay, and this is looking great now. So 2 minus 2 cos squared x. I'm going to add 2 cos squared x to both sides, minus 2 from both sides, and then swap the 2 around. Sometimes also it's good to not get too hung up on the final answer, but just try to, we know we're trying to get a hidden quadratic, but I haven't really been looking at the coefficients that have gone along. If I make a mistake, then I can look for where I've made a mistake or come back to it. But in this case, I've managed to get it exactly the same, so I know I'm good and I must have done everything correctly. In part B, first of all, we have to show detailed reasoning. I would advise detailed reasoning all the time, really, but just we've got to make sure we don't skip any steps and hence solve this equation here. Now it's very, very similar to the first equation, except that x has been replaced by 3 theta. So I'm going to start by just writing the equation down. And we're looking between 0 and 120. Which means that I'm also first going to find solutions for 3 theta. That is actually going to be between 360 because then I'm going to divide it by 3. It's worth being aware of that. Now we can use part A and simply replace my x's here by 3 theta. I just forgot to do it. Right, so 5 cos squared 3 theta plus 3 cos 3 theta minus 2 equals 0. It says detailed reasoning, so I'm just going to say by part A. Now, there's a couple of approaches you can take now. You could use a substitution like y, for example, and let y equal cos 3 theta. I'm tempted to not use x just because we had x here personally, but you could use x. And then I would get 5y squared plus 3y minus 2 is equal to 0. And I've turned it into something that is more familiar as a quadratic, although I can see why you might want x if you want to make it even more familiar. Or we can just treat it as a quadratic in cos 3 theta and factorize it directly from there. It's up to you, really. I'm tempted to just go with just without doing a substitution because you tend, we might need to do a substitution later on for 3 theta as well, but I can talk about how we can avoid doing that as well. But I'm going to go straight for it and factorize. Now, there's a few different approaches. We are told to do detailed reasoning, so you will be expected, I think, to show a factorize. It doesn't say you have to factorize. You'd have to write down the quadratic formula if you're using that. But this will factorize, and you'd kind of expect it to. So if it's going to factorize, it's got to be a 5 here and a 1 here. So 5 cos 3 theta and cos 3 theta. And then there's not many options actually for the 2. It's either 2 here, which is going to give me 10, and 1, that's too big, or 1 here and 2 here. Now I can see as I multiply across, I'm going to get 5, and I'm going to get 2. So that is great if I make this one minus and this one plus. Then I'll get my 5 cos 3 theta minus 2 cos 3 theta. So cos 3 theta is equal to 2/5 or minus 1. Now, I don't advocate the following method, but I do see people using it, especially to check, or if they really struggle with factorizing. And that is, you can go to the equation, polynomial, degree 2, and essentially solve it using the quadratic formula. So it's going to be 5, 3, minus 2. We get answers of 2/5 and minus 1. So what that kind of means, I'm just going to write it in terms of x. It's going to be x minus 2/5 and x plus 1. But at the moment, this gives a coefficient of x squared, and we needed a 5 in there. So I'm going to need to times through by 5. Like that's, you have to put this little kind of correction in. And then if you multiply this first bracket through by 5 to get rid of the fraction, then we get back to 5x minus 2. So I see people do this, especially if the factorization was a lot harder, but you're asked to factorize it, it can be useful. I would say, there's nothing wrong with what I did here though, but that is an alternative. Now, actually, and I could have done this earlier on, I do advocate a little substitution here to help with understanding. So I'm going to let u equal 3 theta, and therefore it's cos u is equal to 2/5 or minus 1. It's a little bit easier to understand the graphs to find all the solutions for cos u, or sorry, for u, and then theta will just be u divided by 3. But I'll talk about both approaches. Now, first of all, I think it's important I always do, I don't use cast method, if you know what that is. I always like to draw the graph. So we're looking, remember, 3 theta between 0 and 360. So it's actually going to be u between 0 and 360. And then up here, I'm going to have y is equal to cos u. So graph is going to look like this. And that is 90, that is 270, and that is 180. Oh, sorry, and then, yeah, 360 here. So let's first of all, actually minus 1 is probably the easiest thing to go with. It's going to be inverse cos of minus 1. And we can actually look at the graph to do this. You can put it in your calculator, but here it is. It's going to be 180 degrees. Not going to be any more in the range. Or it's going to be inverse cos of 2/5. And then we're looking around here. I think it's below a half, and there's going to be two solutions. So one of them is going to be what we get directly when we put it into our calculator. $66.421. I advise writing it to a few more figures because we're still going to have to divide this by 3. Don't round it yet because that can mess things up. Or, well, we use the symmetry of the curve, and this distance is exactly the same as this distance, so it's going to be 360 minus 66.421. $293.578. So theta is equal to u divided by 3. So it's going to equal 60 degrees, 180 divided by 3. I've already got the answer for this one, so I might as well do it straight away from here. 97.9 degrees. Technically, it was 97.85. I like to write it to a few more as well. Or we've got this other one, 66.421. Divide by 3. 22.14. So 22.1 degrees. Those are our 3 answers to this question. And before I go, let me just say one thing. So I did this substitution for you. I just think it like then all works out naturally because it doesn't feel strange when you're drawing the graph of cos u. Whereas it does feel a little bit strange when you're drawing the graph of seemingly cos u when you're solving cos 3 theta. And actually, you don't need to do the substitution. It's just that technically, if you were just to solve it directly and do inverse cos of 2/5 and using the graph of cos, then actually you're drawing the graph of y equals cos 3 theta, but you're plotting it against 3 theta. So that is kind of why it works. That shouldn't be any surprise really because that was my substitution, u equals 3 theta. So I've just replaced u by 3 theta. So actually the graph of cos 3 theta against 3 theta looks exactly the same as cos x against x. And so you don't need the substitution, you just kind of treat it as normally, but that is why. I just wanted to explain that at the end. Hopefully that makes sense. If not, then that's why the substitution is great because you don't have to worry about it. The substitution just deals with it all for you, and then you just apply the inverse, like in this case, divided by 3 at the end, which you have to do anyway after you found 3 theta, but it just kind of makes a little bit more sense.